In this episode, we are going to be covering input elements in DX. There are two main ways to enter signals that you would like to process into DX. What this is going to do is it's going to look in the file for channels that match the channels that have been specified in these elements, and then DX will process only those channels. If you have channels in your file that you don't want to process, removing them from processing will speed up processing time and is generally just a good practice. There are two main input elements. We have the signals element and the parameters element. We classify signals as high speed or high sample rate, and we classify parameters as low speed or low sample rate channels. So for signals, you're looking at things like vane gauges and strain gauges, and for parameters, you're looking at things like speeds and temperatures. There are two different kinds of elements for both signals and parameters. We have signals star and parameters star, and signals and parameters. By default, DX will load in the signals and params elements, but for generalized designs, it's generally advisable to use the signal star and parameter star. We'll get more into how to use those elements in just a moment, but I want to cover the main signals and parameters elements first. To enter a signal into the signals element, simply click the Add button and type the name of the signal. Assuming the name matches the name found in the file, that signal will be processed through the rest of the downstream design chain. Right now I have ACC01 and ACC02 already set up here in my signals element. I can also load signals from a file by clicking on the load button. This will overwrite what I have already in there, that's fine. And I'm going to select the file that I would like to process here. And then I can select the channels that I would like to add to my signals element here and hit OK. It's generally a good idea to keep the channels in the signals element all of the same unit because this is where time domain settings are performed. So in this instance, both of my channels are Gs. That means that I am able to change my coefficient to change the unit type here in my element settings. So I can change it from Gs to meters per second squared or Gs to feet per second squared. I also have the ability to integrate or differentiate depending on the unit type as it is found in the unit table inside of DX. So for instance, I can do 1 or 2 times integration here on Gs. So if I select that, I can now change Gs to meters per second or feet per second, miles per hour, etc. When I change that, all of the scaling will automatically occur downstream of the input channel. If the integration, differentiation, or unit conversion that I would like to apply is not found in the unit table and is not an option here in the type or coefficient, I can check this Apply Sensitivity button to enter my own calculation for that operation. The setup here is value, target units over original units. So in this instance, I would say 2, and then my target units, which could be anything here. I'll just call it demo over G, which is my original unit. And when I click apply, you can now see that the target unit is demo with an asterisk. The asterisk will follow the channel down through the rest of the process and into the viewer wherever units appear to show that this sensitivity has been applied, just keeping a good paper trail for any changes to the calculations made within DX. So I'm going to uncheck apply sensitivity here. We'll go back to Gs and Gs, and we'll come over here to the params element or parameters element. This works exactly the same as the signals element, but again is for those lower speed channels. In the parameter settings, we have min and max value options. We have type. So mine right here, I think is a tach speed. So I can set this up. And then I have a host of tachometer settings as well that I can set up depending on how that was recorded. The signal star and parameter star element functionally do the same thing as the signals and parameters element here, except instead of entering the channels into a list one at a time or loading them from a file, you're able to use a pattern or a wildcard to load those in automatically. So this is good for organizations that want to set a default design and have a naming scheme for different channels across different test programs and want to just be able to load those in automatically. So for instance here, my pattern is star. That is just going to collect everything. If I were to say SG star, that's going to be anything that says SG at the beginning of it and then have any other something past it. So that would include everything from SG00 to SG approaching infinity. This also supports regular expressions, which is a very powerful tool that lets you use different strings and keys in order to get a really specific filtering done. We have a whole document on that available in our documentation that's going to be down in the description below. So I would encourage you to check that out if this sounds like a feature that is interesting to you. We have all of the same time domain settings here. It is important to note that when using these signal star elements, because you're not setting a specific channel and can verify that they're all the same units, to just make sure, double check that the units are all being applied properly in this element. Otherwise, it might be better to use the regular signals element in those scenarios. Finally, the signals element has a plugins option where we have a few different plugins that do different operations. You can read about what each one of them does here in the description and use those if they are applicable to your situation. When loading in channels using design from file, DX will automatically separate the channels out into their different signals elements depending on the units. So here in this file, for example, I have a number of units already in here. So this file includes Gs, IPS, PSI, and a volt once per rev here. And all of those are going to, as is in the default setup, which we'll talk about a little bit more later with these future elements, into an FFT, Advanced Digital Signal Processor, and into the viewer. Any channels that flow into the viewer are available as plots then in the viewer tree.